Okay, starting recording, and I am going to... Yes. Do I have a piece of paper? Are you kidding me? You better buy them lunch or something. You know what coming to school without a piece of paper or a pencil is like? That's like going to gym without running shoes. That's like going to war without a weapon. Okay? Coming to school without a piece of paper, it's called not being prepared. Okay? Don't do that. Yes. Huh. Okay. I am sending off the attendance. Ah. Okay. That's all my terrible emails, and I am going to share screen with a whiteboard. Jeez, why is it taking so long? Okay. Okay, let's do this. As text, we have 1.6. Okay, finding equations given graphs, I guess, or curves. I think that's the best way we can discuss it in a short manner. So long story short, please recall that when you are dealing with a quadratic equation, or any equation from now on really, you could have different forms. In quadratics, we had standard form, which doesn't quite help us, but we also had factored form, where remember, these are and we had vertex form, where h and k are the vertex. Okay. So standard form doesn't quite help us because it's very ambiguous. There's nothing special about it. It's just an equation, and you plug an x and you get a y. You plug an x and you get a y. But for this equation, these two, I guess, variables are placeholders for a very, very, very special part of the parabola. And so, if you are given this in the graph, then you can plug this in, and the rest of the solution is very, very simple. All you need is, as we were saying, one extra point. And under the same breath, you can say the same thing for the vertex form, but we'll get to that after we try some examples. Okay? So on my graph, or just on my minds on that we did on the board, we had something like let's see, let's pretend this is -2, 0. And let's pretend that is 8, 0. And then we had a random point. Give me a random point.
3, 6.
Oh, you gave me vertex. Okay, that's fine. Let's pretend that's 3, 6. But let's pretend we don't know that's vertex. Okay? It doesn't matter. It could be any random point. So I'll write a little text. The graph gave x-intercepts. So let's use an equation form that takes advantage. Right? Why go into hard mode? So this is it. Right? f of x is going to equal a x minus r x minus s, which is the same as x plus 2 and x minus 8. So you're going to plug it in. That 8 value is going to be here. Make sense? Any questions with that so far? Because if you don't understand it, that looks like magic and you're going to end up having to memorize it. Sequel is here. Sorry. Quickly
Good
resend.
morning, and sorry for the interruption. If you guys could try your web attendance again, I really appreciate it. For those teachers who have web attendance, please try your web attendance. Thank you.
Oh. Good morning. Do your absolute best to be here on time. Hey, it worked. Okay, so here, sorry, Jose. I don't have to say, I think you came close to 9. Try to be here on time. For everyone else, excellent. Okay. Let's close that. Okay. There's no like printout. We're just copying by hand. So if you want to copy down. All right, we're almost done. We're virtually done. There's only one thing missing. What's that? Value? The a value. How do we get it? Anytime we want to solve for an unknown, everything else in the equation has to be filled. Like, do you remember? If we had, let's say I had, 3 is equal to x plus 5. This is the only unknown, so it's possible. You can find it. But what if I said something like y equals x plus 5? Can you figure out the value of x and y? No. In the same way, if you have every single variable filled out in an equation, a single equation, you can find the last one. So if we're looking for a, that means we need to fill in x, and we need to fill in something on the other side. That's where the random point comes in. Here, I'm going to color it in green. Okay? Number 3 and 6 is going to be our random point, and it's going to help us find the a value to complete this equation. Let's do this. Ready? When the x value is a 3 plus 2, when the x value is a 3 minus 8, the y value is a 6. Right? For those of you who are following on, you're like, this is really easy. What you're doing is, it doesn't matter what the x value and the y value is. What you're saying is, I don't know what a is, but when the x value is a 3, and the x value is a 3, I multiply this, and it gets multiplied by a random unknown number, and I get 6 as a result. You're testing it. You're testing it with the point. And so, very quickly, I'm going to 5, negative 5. So a is 6 times negative 25. A is 6 divided by negative 25. That's not a very pretty number. Don't blame me. Blame Claire. Just kidding. What we have after all that, because we have our a and our x-intercepts, our final function, our equation is going to be a x minus r and x minus s. There's our equation. So it would look something like that. It's actually much shallower. If I did this more realistically, it would look more like, let's see if I can do this. 6 would be around here. I guess I can't. It'd be more flatter. Something like that. Okay? Any questions? It's very straightforward. Look at what you're given, put it into the appropriate slots, and then find a random point to test it out, and you'll get your A value. That's it. But under the same breath, you can do it with this. So up until now, in my mind's eye, I said you need a minimum of 3 points. That's actually not true. We can actually do this with 2 points, as long as those points are very, very, very special. I just told you that the graph gave me x-intercepts, so I decided to use the factored form, which used the x-intercepts. Can we use this as well then? It's the same process. I'm going to erase this. Let's do a different example. Let's pretend I'm going to use Claire's 3 and 6 vertex, but let's pretend I don't have the x-intercept, so I can't use the x-intercept form. Okay? So here's another example. How about I do a different one this time? I will do, sure. How about I just flip it? 3 and negative 6. How about this time, 3 and negative 6? And it is clear that that's the vertex. But I don't tell you what the x-intercept is, so even though it looks like it's a 1, 0, it's not. And I just say, hey, this is a 4, 5, 6, 7, 12. That's it. Normally, to find an equation, this would be impossible, but we're lucky in that one of the points is the vertex. So instead of using the factor form, we can use the vertex form. As I said in my note, you take what you're given to your advantage. Use it to your advantage. So f of x is going to equal x minus h squared plus k. In the same way, what points do we have? We have vertex, and we have, well, h and k of vertex. Right? So let's test it. Go ahead, Abby. So we use 3 and negative 6. That's done. We shouldn't use it again. So let's test it. What else do we have? Yeah, that's all we have left. We have no other choice. So x is going to be a 7. And the y is going to be 12. And you solve it, and you should get an a value. So that is 12 is equal to 4 times 4, that's 16a minus 6. So 16a is equal to plus 6 plus 6, 18. That means a is equal to 18 over 16, simplify, divide both by 2, 9 over 8. So putting it back, my function is going to be, remember, we're leaving x and y all alone. The whole point is to create an equation where, if you input an x, you can get out a y. So this is your final equation. Any questions? I told you, if you get the hang of it, today's lesson is actually very short and very simple. But if you remember back in grade 10, even this was like half a chapter, being able to create or calculate or figure out an equation for yourself, right? Or if you remember in grade 9, you had these little, like the lines, and then given a point and a slope, you have to create your equation, or given 2 points only, you have to create an equation. Given a line and a perpendicular line, you have to create equations. Do you remember that? At the close to the end of the year. That's all this was. Take the clues from the graph and put it together in a way that helps you. All right? Any questions to this? Probably not. We just have to practice it to see that, oh, this is all it is. Okay? But seriously, any questions? No? Okay. Okay. I'm going to clear this. And this is from the textbook, but I'm just going to write some random questions that you can try in class together. For maybe about, I'm going to give you maybe 20 minutes. It'll be really quick. And we'll take our break before 10 o'clock today. Okay? Because our next section is going to be a little bit longer. Let me clear this. Okay, so from the text, page 57, that would be numbers, I wish I wrote this down, 1, 3, 1, 3, 5 challenge. Oh, 6 is annoying. So 7, that's a hard one. And 8. I would give you the chapter test, but chapter question, but it'll be fine. Let's do 18. So this will be your homework for this section. Let's try this right now. Okay, I'll get it to you. Alright. Sure. About that. How about, here's a hard one. Okay, that might be a little ugly, but it should be fine. And show only 3 data can be read. This is the textbook's chapter problem, so we'll do that together, just to show how interesting number manipulation can be. Right. I don't know. Okay, so this is number 14 from the textbook, but I paraphrased it. Okay, so let's try that together after. Give yourself some time to work on this. We'll take it up. I will get you.
Should we do the textbook problems first or the ones that you?
No, try them now, and then you'll be free to work on the textbook after. Try the ones that I just wrote down. Here is my textbooks. Does anyone else not have a textbook? You don't either? Oh, no, I mean, did I not assign you? You got one, right? Okay. Well, let's grab any one of these, and then we'll get the next one. You got a range of way two. The initial string here. Yes. Sorry, say that again. This or this? Last one?
Yeah, that one. What do you mean? What do you mean?
So if you take a look, we have 5, 8, 9. 6 and 7 is missing.
Oh.
So what would those points be? There is a way to go through a roundabout way and figure that out. Let's resume recording. Right? So use whatever information is most useful and use it in appropriate ways. We have f of x should be a times x minus r, so that's plus 3, and then x minus s, which is a 5. And from there, you know that we have a random point x and y. So if the y value is 4, negative 4, it's because x was a 2. Work that through. 5 times negative 3. Is that right?
Yeah.
Okay, negative 3, 2, and 2 minus 5 plus 3. Okay, that's a 5, and that is a negative 3. So we have a times negative 15. A would be negative 4 divided by negative 15. It would be positive 4 over 15. My final answer should be positive 4 over 15, x plus 3, and x minus 5. Okay. Now that we have this, let's go one step further. If the question asked you for the vertex, how would you solve it? Think back to your lesson from 1.3 and 1.5. Using the x-intercept, what can you do? Go ahead, Claire.
The line of symmetry is going to be like the average of the two.
Mm-hmm.
And then the line of symmetry, like that x value, is going to be the x value for the vertex.
Right, so you plug it in, you're like, if this is my x, what's my y? That's exactly right. Right? Being able to attack it from one way, you're going to be able to unravel it as long as you are thinking about it using your head. Yes?
About the number 8, I saw that it's not it's a 6. I saw that it's 6 minus
Oh, no, sorry. That's supposed to be a 5. That's my fault. But again, if your process is correct, of course the answer would be different from you and me, but you would have done the math correctly. So, yeah. All right, part B. So I tried to throw a curveball at you, but it's nothing different. Again, you're using x-intercepts. Let's follow the process. You have f of x equals x minus one of the roots, so about like 1 plus root 2, times x minus 1 minus root 2. Right? So let me simplify it, because right now it's a little shaky. It would be x minus 1 minus root 2, and this would be x minus 1 plus root 2. I know I gave you roots as x-intercepts, but if you do the quadratic formula, sometimes your roots are in roots. Roots are in roots. Roots are in radical form. Don't be scared by that. You're still working with the same process. If the y value was an 8, x would be a 1. 1 minus 1 plus root 2. You end up getting a 1 minus 1, so negative root 2 and positive root 2. You multiply that out, this becomes negative 2. A value is going to be 8 over 2. It's going to be a 4. My final equation is going to be this not so pretty one. Any questions? I went a little fast, but yeah.
Positive 4 or negative 4? I thought negative.
It'll be negative 4. Thank you. You're right. So 8 divided by negative 2 would be negative 4. Negative 4. Sorry about that. Yes?
I would know what if 1 minus root 2 should be minus 0.414. So it should be, so these two roots at two ends of the x. I don't know how to explain.
Which line? Second one?
Yeah, the second one.
Okay.
So for 1 plus root 2
Yes.
For 1.
Yes.
And 1 minus
Yes.
2 is minus.
Yeah.
One should be plus and the other one
You
should be minus.
you could turn it into decimals. But the reason I want you to not turn it into decimals is because you don't have the perfect exact answer. Okay.
The first line
Mm-hmm.
one. I think should be x minus 1 minus root 2 and prime x plus 1 minus
Oh, no. That's not positive. It's still positive 1 plus this, and it's still positive 1 minus this. Think about it. Here, let me rewrite it. 1 plus minus root 2 means it's this or that.
2. Yeah, I know.
Okay? So look. Remember, the formula is x minus s, or x minus r, x minus s. So they're both minuses. Think about it.
Can we talk after?
Yeah, absolutely. Okay, so for the next bit, I'm going to clear all of this while trying to keep this text portion. It's a kind of a word question. It's a little bit different. Oops. Okay, so here we have a data set, and some of the portions are missing. Will you get something like this in real life? I don't know. Okay, but the idea is this. I'm going to draw it in blue first, just to give you an idea. At 1, 2, 3, 4, 5, the x value was, let's say, 22. Right? And then 6, 7, 8, it was 28. And then at 9, it was back to 22. Okay? I do not know what the other portions are. So what this person did in the textbook, or in this case you decided to subtract everything, all the y values by 22, which means I am vertically shifting everything down 22. My 522 becomes, I'll use black, here. My 828 becomes 6. And my 922 just becomes 0. So the question is, what are those? What I'm trying to get to, or what this question is trying to get to, is right now these 3 points are nothing special. There's nothing particularly powerful or revealing about these 3 points. But we manipulated and turned this point and that point into x-intercepts. So now we have 2 x-intercepts and a random point. How does that help us? What does this allow us to do by bringing it down? Yes, Elliot?
Find the equation and do the transfer again.
Right. You can find the equation using those 3 points because we just learned that. And that means these 2 are no longer a mystery. Go ahead. See what you can do. Something like that requires a little bit of creativity, but just got to get used to it. And once you see how often number manipulation occurs, at some point you'll be comfortable doing your own number manipulation to help calculations. And easier. Yes. For C, I do not know. But just try. Boom, 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 boom. Minus to be negative 2. What did you plug in? What did you plug in? What did it? How did you find 28? Oh, I know, I know, I know. You used the bottom numbers, right? And then you plugged in 8 to 28 and stuff. You could use the bottom parabola and then move it after. Oh, what? Yeah. The 22. You could, but right now, let's pretend, forget the blue dots, okay? Let's pretend that's all we have. And then once you solve that, you can just raise it up to make it afterwards. Don't worry about that now.
Oh, yeah.
So number manipulation is supposed to make your life easier. Another couple minutes. Yeah, I know what you're saying. You know this? Or maybe I should use this. It's not actually here, here. It's actually as a one. One of the roots is, the other root is, it's still positive. Oh, sorry, it's right here. It's still there. That doesn't make anything different. It's still, so this part here, right, is what? 1 plus root 2, right? So my x value is, and this is 1 minus root 2. Right? So you take this number, the entire number right here, and you subtract it. So what is subtraction of 1 plus root 2? And what is subtraction of 1 minus root 2? Hold on. This is a 5 minus 1. What is it? X minus 5 and x minus negative 1. Right? That's what becomes x plus 1. Okay? Same way, I just take this number and it's minus that number. Okay? X minus 1 plus root 2 with x minus 1 minus root 2. You got it? Yeah. I know what you're doing. I know what you're like. I get it. I get it. So don't worry about it. It makes sense that it can be confusing. Yep. Yeah, yes, that is correct. So this would be the blue, right? But without, yeah. Yes. So this would be the black one, right? Yeah. So if you want to show the blue one, just go vertical transition. Yeah. Yeah. I know, we did transformations only for a vertex form, right? Like the H and the K, like that's supposed to be, you know what I mean? But we learned that whatever is adding to the function will cause the entire function to shift up or down. So even if it's a factored form, you can do that. And in the same way, what are the x values for 6? What's the y value if you plug in 6? You're like 6 minus 5, 6 minus 9, right? So you're adding 22. So it's the same thing as this. Yeah. Dude, we did that last class. Yeah. One more class. Look at your hand up. So why do you think I'm giving you the square roots? Because you will see it, right? All right. Let's work this out. Okay, so ignoring the blue, if we only, am I recording? Oh, I've been recording all this time. Ignoring the blue, if I were to be working with the black parabola, I notice that I'm given the x-intercept, or rather I have the x-intercepts. I turn these points into x-intercepts, right? So that I can make life easy for myself by doing this. I also have a random point, thankfully, giving me this. We have 3 times -1, that's a -3. A is a -2. So my function for the black parabola is that. Okay, if that's the case, what would be these points for my black parabola? I plug in a 6, I get 1, -3. F of 6 is going to be 1, -3, that's a -3 times, that's a +6. That would be 6 and 6. If I plugged in a 7, that would be 2 minus 2, -4 times -2, +8. That point is 7, 8. Oops. If that's the case, what are my original points? Right up here. Just as before, when we translated down 22, all we have to do is simply take these y values and translate it up 22. If you don't like what I'm doing here by just adding randomly, know that if this is our black parabola, to transform it vertically upwards, translate it vertically upwards by 22 units, all you have to do is add 22 to the very end of it. Just like how in grade 10 you were limited to the vertex form, that was supposed to tell you how much we moved up vertically, right? It's basically you are adding this k value to a function that's already there. The concept doesn't change just because we have a different equation form. It doesn't. We just add and it's going to shift it up. Okay? So the answers to this question, what is the original point? It would be 6, 22 plus it would be 28, and 7, 30. Those are my 2 points. Okay. Why are we going through this? Why is there a full section on this? Again, from my little spiel last week about, letting math work for you and how it's applied in a variety of places in this world. Think places like science or any place you collect data. Let's say you do a survey. Let's say you do some kind of some kind of data collection, and it creates a pattern. Your data, your experiment, is not going to give you an equation. You're supposed to get a line from your data. You're supposed to pull an equation by yourself so that you can use it in other places. So this little bridge from data to equation will help you with all the practice you had from equation till answer or whatever. Okay? You got to be able to go back and forth. It is now 10 o'clock. I'd like to give you a 15-minute break. Please, you go to the washroom and do whatever you need to. And then after that, we're going to start off with both 1.7 and 2.0. Okay? Yeah. Take a break, and we'll reconvene at 10:16.